contest to figure out which computer was the most ahead of its time, I would absolutely nominate the Commodore Amiga. I mean, this computer, when it came out in 1985, could do things that most computers couldn't even dream of, and a lot of people couldn't even believe. It took until the 90s before a lot of other computers could catch up to what this computer could do in 1985. So in this episode, we're going to take a look at the original Amiga 1000, and we're going to figure out how it works and what made it so ahead of its time.
By 1983, nearly every computer company was looking to build a 16-bit system to sell alongside their 8-bit systems. Many of these you will recognize, such as the Atari ST, the Apple Macintosh, and later the Apple IIGS, the IBM PC-AT, and of course the Commodore Amiga. Of course, there are other 16-bit systems, although many people will be surprised to find that the first 16-bit home computer was the TI-99-4, which came out in 1979. However, due to the kludge design, it performed as bad or worse than most 8-bit computers. But if I didn't at least mention it, some people would be upset. All of these computers have interesting stories behind them, but obviously we're going to focus on the Commodore Amiga at the moment. The relationship between Commodore and Atari around this time is complicated. But in a nutshell, the CEO of Commodore left and moved over to Atari, bringing with him many of Commodore's chip designers and engineers. And around that same time, several of the original engineers at Atari left to create a new company called Amiga and create their next generation design. This left Commodore without the ability to engineer its own 16-bit system in a reasonable amount of time, so they ended up buying Amiga, thus completing the cycle so that now a significant portion of employees had totally switched places. And while we tend to think of the C64 as being the predecessor to the Amiga, in many ways it would be more accurate to say the Atari 800 series was the real predecessor. So let's take a quick look at the outside of the Amiga. You get a nice external keyboard, which was not normal for Commodore at the time. And one neat trick is that when not in use, the keyboard can slide under the computer so you have more desk space. On the front, you get a 3.5-inch floppy drive that stores 880K per disk. On the side, you get two regular Atari-style joystick ports, although port 1 is almost exclusively used for the mouse. And by the way, the mouse was shipped with the computer. It was not an optional accessory like most other computers at the time. On the rear, you get the keyboard port, parallel port, external disk drive, serial port, and left and right stereo audio. Believe it or not, all three of these ports are video. This is the analog Rgb port. This one is more similar to that used by the 8-bit system, so you'll need a breakout cable like this one to connect to a composite monitor, or you could use an RF modulator like shipped with the VIC-20 to connect to a television. And this last one is just a regular RCA color composite output. So how does composite output look on the Amiga 1000? Well, as you can see on my CRT television, it's totally usable. I mean, most everything is readable and the colors are pretty good. Admittedly, 80-column text on a black screen comes out rather blurry, but you can still read it. But this sort of screen is rare on the Amiga, but if you're doing what 90% of Amiga users were doing, which was playing video games, it looks totally fine. There's really no reason you had to have an RGB monitor for this. That being the case, I have my Commodore 1084 monitor here, which has a button where we can switch between composite and RGB, and this will let us instantly see the difference between the two. So this is RGB we're using now, and here's composite. And now back to RGB. So yeah, you can see the difference in clarity. Of course, you didn't have to use a Commodore monitor. Any analog RGB monitor would work if you built your own cable. As an example, I built this cable to connect to my RGB modded television, and as you can see, it looks super sharp and crisp here, just about as good as the Commodore monitor. One other option for modern Amiga users would be something like this. This converts the RGB signal into component video that was common in North America here from late 1990s to the 2000s. This will allow you to connect a somewhat modern television to your Amiga and get better video quality than composite. The original Amiga was built like a tank. I mean, everything from the power supply to the individual switches on the keyboard, you won't find any of the cost-cutting philosophy that was common at Commodore at the time. While we're looking inside the computer, I want to show you the inside of the top case. It has signatures from all of the developers of the computer. You'll see names like J. Miner and the paw print of his dog. Oh, and here's RJ Michael, who worked on the operating system, and I nominate him for having the coolest looking signature here. Let's take a look at the architecture of the Amiga. The four primary chips we'll talk about are the CPU here, and then the Agnes, Denise, and Paula, which function as memory controller, video, and audio respectively. The CPU was the Motorola 68000, a 16-bit CPU with even some 32-bit internal registers. It runs at 7.16 MHz. Now you might think it would be 7 times faster than the CPU in the Commodore 64, which runs at 1 MHz, but that's not actually the case. The 6502 and its variants are very efficient and perform a lot more operations per clock cycle than the 68000. In fact, if both CPUs were clocked at 1 MHz, the 6502 would achieve 0.43 MIPS, whereas the 68000 would only achieve 0.175 MIPS. But since the 68000 is clocked 7 times faster, it ends up being 1.25 MIPS, which means it's about 2.9 times faster than the C64. So yes, the CPU is more powerful, but probably not as much as people might think. So where the real performance of the Amiga comes from is all of its coprocessors. So let's have a look. We'll start by taking a look at the Denise chip, which provides video for the Amiga. Denise doesn't really have a text mode like other computers had at the time. It produces bitmap graphics only, thus any screens that you see that look like text mode is actually just text characters drawn on a bitmap graphics screen. It can also produce 8 hardware sprites, although these aren't nearly as useful as they were on the C64, which you'll see why shortly. Denise is also responsible for reading the XY inputs on the joystick ports. The resolution of the graphics chip is hard to nail down to a specific number. There were a number of common operating modes. Games typically used the 320 by 200 mode, which gave higher color depths and speed, but productivity applications tended to use the higher resolutions such as 640 by 200. Of course, these are NTSC resolutions, so on PAL the vertical resolution is increased. But the Denise chip was highly customizable and other resolutions could be programmed, which we call overscan, and that's because they might not fit on your screen. It could also produce a color palette of 4,096 colors, something almost unheard of at the time. Of course, it couldn't display all of those colors on the screen at the same time. The Amiga used planar graphics. I'll try to explain how that works. I'll use the C64 as an example. At its heart, the C64's high-res mode is just a single monochrome screen. Each line of graphics on the screen is represented by 40 bytes of data, and within each of these bytes are 8 bits, which represents 8 pixels on the screen, being on or off. You could consider this monochrome screen as being a single bit plane. Now, the way that the C64 added color was to divide the screen into 1,000 different little attribute areas where you could define foreground and background colors. This allowed adding 16 colors to an otherwise monochrome screen at the expense of only 1,000 bytes of RAM. However, this created a lot of challenges for coders and artists to figure out how to work around this limitation because it was often not possible to put very many colors next to each other. Some other computers of the era might accomplish full-color screens by having 1 pixel represented by 4 bits, and thus you get 16 colors, and you can still nicely fit 2 pixels evenly into 1 byte. You wouldn't want to do an odd number of bits because this would not line up and therefore overly complicate the video RAM lookup for both the video hardware and the coder. That means systems employing this type of graphics usually have to go with 2 colors, 16 colors, or 256 colors to make it fit nicely. Now let's take a look at how the Amiga does things. Imagine this being our first bit plane. Obviously there'd be way more pixels than what are shown here, but for illustration purposes, bear with me. On the Amiga, you can activate anywhere from 1 to 5 bit planes, and each one of these is sort of like a monochrome screen, and these are layered on top of each other. So in this example with 5-bit planes, let's look at the top right pixel as an example. The video chip will take all 5 overlapping pixels and use this to form a binary number between 0 and 31, thus giving you a color index for a single pixel, allowing you to pick between 32 different colors. Of course, it doesn't have to be these colors. You can actually program a palette from the 4096 available colors. And if you go with a single bit plane, then you get 2 colors, 2 plane gets you 4 colors, then 8 colors, and so on. And each mode offers a trade-off. The more planes you use, the slower the screen updates are, as well as the more RAM required. But on the other hand, more colors provides better looking graphics. Even in 16-color mode, the Amiga does graphics that are far superior to the Commodore 64. So for example, here's the same game on the Amiga and the C64. Both are running in the same resolution and color depth. But the Amiga looks so much better. Now this is mostly due to the fact that the Amiga doesn't have any color cells to worry about. You can put any color pixel next to any other color pixel. Also, the Amiga has more RAM, so more complex graphics can be stored. The Denise and the Agnes actually work together for a lot of functions, and while I said the Agnes is a memory controller, that would be something of an understatement. Within the Agnes, you will find copper and blitter. Agnes is actually responsible for producing the vertical and horizontal sync positions of the screen, and the copper makes use of this feature. It can be programmed to automatically change registers within the video display at a specific time during the screen draw. So for example, this is a simple 2-color bitmap, but the copper changes the color as the screen is being drawn. No extra video RAM is required to accomplish this. It can also change things like sprite positions or really just about anything you want. The blitter, which is short for block image transfer, is designed to copy small or large chunks of data without the CPU having to do the work. And so when you see something like this, for example, you'd be tempted to think these asteroids are hardware sprites, but they aren't. Sprites are much smaller than this. The blitter works so well that the Amiga honestly doesn't even need sprites most of the time. The Paula is often referred to as the sound chip, but it's also in charge of running the floppy drives, serial port, joystick buttons, and it's the interrupt controller. The Paula is not a traditional synthesizer. In a nutshell, it's a 4-channel digital sample player. In fact, it's surprisingly similar to a Casio SK series sampling keyboard of the same era. This gave the Amiga a unique sound for the era. This is an example of a 4-channel mod tracker file, which was designed for music composition on the Amiga. Interestingly enough, the CPU barely has to do any work to produce this music. The Paula chip is handling just about all of the workload, and that's why video games like this could have both amazing graphics happening on the screen and amazing music and sound effects being played, while the CPU is barely doing any work. Due to these various coprocessors, the Amiga could do things that other computers couldn't even come close to. You might think of computers like the Apple II or the IBM PC as being a one-man band. The CPU has to do pretty much everything. On the Amiga, the CPU is more like the conductor of an orchestra. Oh, and there's one more feature I wanted to talk about on the Denise chip, which are 2 other graphics modes. One is called Ham mode, which stands for Hold and Modify. The other is called Extra Half Bright mode. Both of these modes allow the Amiga to use more colors at the same time, but not in the way that you might think. So imagine this is a row of pixels on the screen, and of course keep in mind the electron gun is drawing the pixels from left to right. And you can define a pixel based on one of 2 criteria. You can of course select a color from a palette of 16 colors, or you can choose to define a pixel based on what makes it different from the last pixel drawn. This mode allows for some truly breathtaking pictures to be created, especially when putting it into context that this technology came out in 1985. Now, as cool as some of these images looked, these modes were rarely used for games. The trouble is, since many pixels are dependent on the pixel that comes before them for color, it's hard to draw moving objects on the screen because it would cause horrific artifacts when you start changing pixels around. So this was typically used for still images only. Now, I remember that Commodore Magazine used to have these art contests for the C64, and people would draw pictures using things like Doodle or Koala Painter and submit them to the magazine. And these were always cool to look at as a C64 user. But once they started including art for the Amiga, it was a real game changer. I mean, there was just no comparison. And by the way, I don't know what these judges were thinking, but this picture of the sword should have totally been the winner. So I've made a number of comparisons with the C64. In fact, here's the C64 version of Defender of the Crown. But let's compare other 16-bit systems of the time. Here's the Macintosh version. Now, keep in mind, all Macintoshes at this time were still using 2-color monochrome. Here's the MS-DOS version and glorious CGA, and while most MS-DOS users at this time still had CGA graphics, to be fair, EGA had just come onto the market, so let's have a look at that version. Keep in mind that there was no standardized sound card for MS-DOS computers at the time, so this is pretty much what you got as far as sound. So the truth is, the Commodore 64, a lowly 8-bit computer, was still considered one of the best gaming computers available at the time. But even it can't compare to the Amiga, which looked like this. Of course, the Amiga brought about entirely new genres of games. Since every Amiga shipped with a mouse, game developers were able to start making games that relied on mouse controls instead of a traditional joystick. The Amiga was starting to become the primary platform for new games to be developed on before porting to other systems. Let's talk about expansion options for a moment. Obviously, every Amiga included a disk drive, so there was no need for cassette storage or anything like that. Commodore also made an external disk drive. Now, these disk drives were not like previous Commodore drives, and there's no CPU or anything inside of these. The controller is on the Amiga's motherboard. Thus, these drives were somewhat cheaper to produce. Now, notice that the drive has another port on the rear, and this is for daisy chaining, and you could have up to 4 floppy drives total, and they're referred to as DF0 through DF3. DF stands for disk floppy. Now, while the Amiga 1000 shipped with 256K of RAM, there is an expansion RAM socket hidden in the front where you can add an additional 256K. In fact, it didn't take long before 512K actually became the standard base RAM for the Amiga 1000. There's also an expansion port on the side. Now, this gives full access to the system bus, and all manner of expansion options became available for it, including a module for MS-DOS compatibility, hard drive bays, memory expansions, and even CPU accelerators. Although I should probably explain that not all RAM on the Amiga is equal. You see, the 3 coprocessors also share access to some RAM with the CPU. Now, this is called chip RAM. This would typically be the onboard RAM and the expansion RAM bay. Any additional RAM added by the side expansion would be called fast RAM, because this RAM could be accessed by the CPU on every cycle since it's not shared with the coprocessors. Which kind of RAM is better depends entirely on what the software needs to use it for. Chip RAM is often preferred because you can store your music samples there for the Paula to access, as well as graphics RAM for the Agnes and Denise. And one last expansion to talk about is this. This is called a Genlock. It actually fits perfectly into the bottom of an Amiga 1000 like this, and its purpose is to allow the Amiga to overlay text and graphics on top of an existing video signal. Now, normally this would be hard to do because any 2 given video signals are likely to be out of sync, but the Genlock synchronizes the 2 video signals so they can be blended together. Now, this allowed the Amiga to be used in video production work. The Amiga could be used for something as simple as overlaying a phone number on the screen, or even something more elaborate like showing a weather forecast.
So I've told you about the Amiga's hardware, which was really groundbreaking at the time, but now I want to tell you about the operating system, which was just as groundbreaking.
I know I said the original Amiga had 256K on the motherboard, but that's not entirely true. This daughter board contains the WCS, or Writable Control Store. It's 256K of RAM, and it's designed to hold the operating system. That's why when the Amiga 1000 powers on, it shows this image on the screen saying it wants a Kickstart disk. At this point, it loads Kickstart into the WCS, and then it asks for a Workbench disk. Of course, at this point, you could insert a Workbench disk or any other bootable disk, such as a video game. It won't ask for Kickstart again, even after it reboots, unless you completely power the system off. And that's because the WCS RAM is designed to become write protected once Kickstart is loaded in. Incidentally, the way you restart an Amiga is by holding down both Amiga keys and then pressing Control.
Believe it or not, this setup was actually more expensive than just putting a ROM on the motherboard. In fact, that's what all later Amigas did. They had the ROM on the motherboard. So why did the 1000 use this bizarre WCS setup? Well, it turns out that Commodore wasn't quite finished with the operating system at the time of launch, and they thought it'd be easier to update the operating system by sending out floppy disks rather than replacing ROM chips on a motherboard. So, believe it or not, that's, of course, fairly common these days for companies to send out products that aren't entirely ready and then fix them later. So for better or worse, Commodore was actually ahead of its time with that philosophy as well.
Of course, it's possible to upgrade an Amiga 1000's motherboard with a Kickstart ROM. I happen to have another Amiga 1000, and this one has in fact been upgraded. So let's take a look to see what makes it different. Notice that this one has been upgraded with a Motorola 68010 CPU, which is a drop-in replacement that's about 10% faster than the original. But that's not what we're here to find. The secret is under the floppy drive. If you look at the original motherboard, you'll notice it has 2 ROM chips here, and then these 2 are blank. Well, in the modified Amiga, all 4 of these have socketed ROM chips installed, and so this computer doesn't need a Kickstart disk. Enough about Kickstart, let's talk about Workbench. It had a graphical user interface, which wasn't necessarily groundbreaking at the time, as Apple had already been offering this for 2 years since the launch of the Apple Lisa in 1983, and the Macintosh the following year. But Workbench was not only in color, but it had something nobody else had at the time: real multitasking. Keep in mind that Apple didn't add multitasking capability to the Macintosh until 1987. But Workbench wasn't just multitasking, it used preemptive multitasking. The main difference being that with cooperative multitasking, the operating system hands off control to an application, and then each application hands off control to the next application when it's ready. With preemptive multitasking, the operating system both gives control and takes control away when it's ready to give CPU time to the next application. That means that no one application can hog the system or even freeze the system if it crashes. As you can see here, I have several different windows open with different tasks running in them, and the Amiga is handling it like a champ. Most consumers wouldn't get this kind of multitasking until 10 years later when Windows 95 came out. And by the way, this isn't a purely graphical interface. There is a CLI or command line interface as well. And it works more or less like you'd expect. There are familiar commands like dir for directory, cd to change to subdirectories, and you can even execute programs from the command line. To close the CLI, you can type end CLI. Also built into Workbench was speech synthesis. They included a little demo program for you to test this out.
Thank you for watching the 8-Bit Guy.
It sounds a little bit like Stephen Hawking.
I sound like Stephen Hawking.
Well, that didn't come out right. Let's spell it differently.
I sound like Stephen Hawking.
That's a little better. Workbench was originally presented in 4 colors because 16 color mode used too much RAM and it was kind of slow, but you could at least define your own color preferences if you wanted. Later versions of Workbench would, of course, move to higher color modes. With Workbench, you also got a disk called Extras, and one of the things on the Extra disk is Microsoft Basic. Of course, this version has been designed for a windowed environment, so you have the list menu where you can edit the code, and then an output window where it's executed. And so here's how that works. Of course, it isn't limited just to text. Basic did include features to draw graphics and even make music. In fact, Basic could actually activate multiple different windows for program output. This little demo is an example of just that. It was really powerful stuff for the time. Of course, there were third-party productivity applications such as this one. It offered full color, what you see is what you get style editing, something still relatively new at the time, and you can even include full color artwork. As you can see, the Amiga wasn't just limited to playing video games, it could handle real business tasks. One interesting quirk of Workbench is that icons do not have a set size. They can be any size you want. This one here, for example, is quite large. Also, icons can have 2 distinct images, one for clicked and one for not clicked. While most game disks are directly bootable without loading Workbench first, many games can also run within Workbench, allowing you to switch back and forth between the desktop and a full-screen game. Another strange quirk of Workbench is the drive clicking. If you leave any drive without a disk in it, it will periodically make a click noise as it checks to see if a disk has been inserted. Many users found this behavior annoying, and the easy solution is just to make sure you leave a disk in all of the drives. So, how did the Amiga compare to other 16-bit competitors of the time in terms of pricing? Well, the Atari ST would set you back $999, but that's nothing compared to the Macintosh at $2,500. And even that pales in comparison to the IBM AT, which retailed for $6,000. The Amiga had a relatively low price at $1,285 at introduction. Of course, this price soon fell over time. In fact, somebody found this vintage price sheet from a computer store in 1988 and uploaded it to social media. This is 3 years later, and the Amiga 1000 was being sold for $699. And you could even get the sidecar, which gave it full IBM PC compatibility, for another $499. So for $1,200, that was like getting 2 computers in one, and still cheaper than a real IBM PC. Amigas sold in countries outside of the USA usually had the Commodore badge on the bottom left, like this, whereas Amigas sold in the USA didn't include the Commodore branding for some reason. The Amiga 1000 was rarely, if ever, sold in the same stores that sold the Commodore 64 and other 8-bit systems. Commodore felt that keeping the Amiga in specialized computer stores rather than department stores would help shape an image that the Amiga wasn't just a toy. And of course, Commodore would eventually drop the Amiga 1000 in favor of newer Amigas like the 500 and 2000, which we'll cover in a later episode. And now I'm going to leave you with a montage of games for the Amiga, and while you watch these and see the graphics and hear the music, I want you to think about the fact that this hardware was released in 1985. That was years before the Sega Genesis or Super Nintendo came out.
There's Boar's ship. Oh no!
Okay, and if you're still here after 28 minutes, then hopefully you've developed an understanding and, better yet, an appreciation for exactly what a quantum leap the Amiga was in 1985. It was far more advanced than anything else that we had at the time. And there's a lot of other things I wanted to cover in this episode. For example, how you can emulate a Macintosh or an IBM PC or even a Commodore 64 to some degree on one of these computers. I also had a number of peripherals I wanted to show off, as well as all of the later model Amigas like the 500 and 2000 and 600 and 1200 and 3000 and so on and so forth. But there's just not enough time in this episode. So what I'll be doing is I'll be coming back with a later episode where I'll cover the later model Amigas and maybe a little bit of the history and the decline of Commodore, as well as some of the peripherals and other things that I wanted to touch on in this episode. But you'll just have to wait for those, so stick around, and as always, thanks for watching.